Okay, so hello and welcome back. So the next question is question number 8, and we have find if the ratio of the fifth term from the beginning to the fifth term from the end in the expansion of this binomial is square root of 6 to 1. So we have basically find n if basically the ratio of the fifth term, the ratio of the fifth term from the beginning to the fifth term from the end, from the beginning to the fifth term, from the end of in the expansion of square basically the fourth root of 2 plus 1 over the fourth root of 3 raised to the nth power is square root of 6 over square root of 6 to 1, I'm sorry. Okay, so to solve this problem, first you need to find the fifth term from the beginning and from the fifth term from the end. So to find the fifth term from the beginning, that's not difficult. So that would be simply t of 5, and then you can basically find it based on the formula that we have. So we have t of r plus 1 is equal to n combination r, a raised to the power n minus r, b raised to the power r. So then based on that you can calculate t of 5. But the term from the end, we need to find the relationship between these terms, for example the rth term from the end and basically the nth term from the beginning, and we will have to do that. Okay, so the fifth term of this expansion, of course we can calculate, but let's see if we can find the rule for the fifth term from the end. So you know that basically if you have a plus b raised to the power n, that would be n combination 0, a raised to the power n plus n combination 1, a raised to the power n minus 1, b raised to the power 1 plus n combination 2, a raised to the power n minus 2, b raised to the power 2, plus all the way up to basically the last term would be n combination n, a raised to the power n minus n, b raised to the power n, and then the term before that becomes n combination n minus 1, a raised to the power n minus 1, which is equal to n minus 1, n minus n plus 1, which is equal to a raised to the power 1, b raised to the power n minus 1, right? The term before that becomes n combination n minus 2, a raised to the power n minus n minus 2, which is equal to n minus n plus 2, a squared b raised to the power n minus 2. And the term before that becomes basically becomes a raised to the power n minus 3, for example, n combination n minus 3, a raised to the power 3, b raised to the power n minus 3, and so on and so forth. So what this means is that basically the last term over here becomes n combination nb raised to the power n. So the last term over here becomes, so basically this is the term number from the beginning. This is the term number from the beginning, and this is the term number from the end. Right? So if I write this, basically, first of all, we have if I know basically what my R is, at these terms, so meaning that if I write my R over here and my R over here, then I can simply calculate the terms, because no matter what term I'm looking for, I know that T of R plus 1 is equal to n combination R, a raised to the power n minus R, b raised to the power R. That remains constant for all of these terms. Now if I can find some relationship between the R in those terms, then we will be able to do something. Now the first term that we have over here is n combination 0 a raised to the power n, right? So n combination 0 a raised to the power, so that means that at the first term, your R is equal to 0. At the second term, your R is equal to 1. And so at the nth term, your R is equal to basically n minus 1, right? And at the n plus 1th term, your R is equal to n, right? Your R in the term is equal to n, which means that basically that the relationship between these two numbers, is always, so you have always 1 here and 0, 2 here and 1, n minus 1. So the relationship is always n and n minus 1, meaning always at the nth term from the beginning, at the nth term from this is basically term from the beginning. The value of R is equal to basically at the nth, basically always at the nth term, the value of nth term from the beginning, the value of R is n minus 1. n minus 1 and n minus 1, meaning that over here you would get a 0, and over here you would get a 1, meaning at the nth term you would get a n minus 1. Now let's forget about all of these over here and write this in a different way. So basically this is basically the term from the, let's assume that this is the term from the beginning, right? The term from the beginning. And this is the term from the end. Now the first term from the end, the value of r over there is basically n. The value of r over there is n, because you have, as you can see, this is the value of n. The second term from the end, the value of r is basically n minus 1. The third term from the end, the value of r becomes n minus 2. Until you can say that at the nth term from the end, that the value of r becomes the nth term from the end, which would be basically this term over here. If you start counting from here, this would be the nth term from the end. That would be, the value of r would be 1, and at the n plus 1th term from the end, the value of r would be 0, right? So you can see that there is you can see that basically when you are talking from the first term from the we are talking from the first term from the beginning, the value of r is 0 there. And when we are talking about the first term from the end, the value of r is n over there. And then it just keeps, basically, you can just keep subtracting from there until you get to the value of the value of r that you want, that you're looking for. What that means is that if you pay attention to this rule over here, if you're looking for the number of terms from the beginning, meaning that from the first term from the beginning, that the value of r starts from 0 and goes all the way up to n, right? And if you're looking at the terms from the end, you know that from the first term from the end, which is essentially the last term of the expansion, the value of r is n, and it is decreasing by 1 as you go through the terms towards the beginning of the end, towards the beginning of the terms, right? So it's now very simple. Now we understand how this thing basically works. Which means that I can simply say that, now simply say that basically at t of 5, which is basically the fifth term from the beginning, r is equal to basically 1 less than this term number, because the term number starts from 0 and 1, 2, 3, and so on and so forth. So r would be equal to 4, right? And at the fifth term, from the end, the value of r is going to be equal to what? R is going to be equal to basically the first term from the end. The value of r is equal to the value of r over there is equal to basically n, right? N combination n. So the value of r is going to be equal to n. So that's the first term from the end. The value of r is going to be equal to n. The second term, the value of r is going to be n minus 1. The third term, the value of r is going to be equal to n minus 2. Which means that basically, at the fifth term, basically, the fourth term from the end, the value of r is going to be equal to n minus 3. The fifth term from the end, the value of r is going to be equal to n minus 4, right? So r is going to be equal to n minus 4. So that's very simple. Now you can of course find some relationship between these numbers and the number that you have over here. So over here you have for example 2 and 1 3 and 2 4 3 and 5 4. So you can write it as basically, if you call this the rth term from the end, then you can call this, for example, the r in the formula would be basically here, for example, n minus, for example, r minus 1, right? Over here again basically over here again the r in the formula would be equal to n minus, for example 3 minus r minus 1, and so on and so forth. So that's always there. Even in this case you can see that this is n minus 0. So you can write this as n minus basically r minus 1. So 1 minus 1 is equal to 0, 0, that becomes n minus 0, which is equal to n, right? So now that we understand how this thing works, of course you can write this down if you need to, but I'm not really sure if, and whenever you need this you can essentially derive it. So there is no need to worry about that, I suppose. So it wouldn't be the worst idea in the world to write this down, but then you would have to create the right notation for this, meaning that the way that I now talked about this, that hopefully you have understood me, but the way that I talked about this, it was essentially a little bit ambiguous, meaning that, for example, I said that the rth term from the end, and then the r in the formula becomes that. So now I have used r in two different senses. So I have to, if I want to write this down, I have to essentially create the right basically notation for that and everything, which would essentially, I would essentially be writing a book, right? At least at this stage, I don't really have the time to do that sort of thing, and it's not really necessary, so I avoid basically doing that, at least for now, right? So now that we have basically the term numbers, now we can calculate basically everything that we need to calculate. Okay, so now to calculate t of basically t of 5, to calculate t of 5, we have basically at t of 5 basically your r is equal to 4. That means that you have basically, we are talking about this thing over here, which is basically the index is n, and therefore I write this as n combination 4, and then the first quantity is the 4th root of 2, the 4th root of 2 raised to the power n minus 4, and the second quantity is 1 over the 4th root of 3, 1 over the 4th root of 3, right? And that raised to the power 4, right? And so n combination 4, a raised to the power n minus 4, b raised to the power 4, and that you can simplify as basically n combination 4. So you have you can write this as basically essentially the 4th root of 2 is basically the 4th root of 2 is the same thing as basically 2 raised to the power 1/4, and if you if you raise that to the power n minus basically n minus 4, you would get basically n minus 4 divided by 4. That would be 2 raised to the power n minus 4 divided by 4. So you can basically write this instead of this, so you can write this as n combination 4, 2 raised to the power n minus 4 divided by 4, and then basically the fourth root of 3 is the same thing as 3 raised to the power 1/4. Raise it to the fourth power, you'll get the 3. So that's, and 1 raised to the fourth power is equal to 1, so that's 1 over 3. This whole thing becomes 1 over 3, 1/3. So that is basically this term is the fifth term from the beginning. This is the fifth term from the beginning. Now, to calculate the fifth term from the end, we have to calculate the fifth term from the end. We have n remains the same because the index remains the same, and the index and the r basically is equal to n minus 4. The first quantity is the fourth root of 2. The fourth root of 2 raised to the power n minus 4. N minus n minus 4, which is n minus n plus 4. So that's raised to the power 4. And the second quantity would be 1 over basically 1 over the fourth root of 3, 1 over the fourth root of 3 raised to the power n minus 4, right? And that's the same thing as basically, so you can write this as n, combination n minus 4, and 2 raised to the power 1/4 raised to the power 4 is equal to 2 raised to the power 1. So you can simply write 2, and then over here you have 1 over the fourth root of 3. The fourth root of 3, so 1 over, so that would be 1 raised to the power n minus 4 is just simply 1, and the fourth root of 3 is 3 raised to the power 1/4, and raise that to the power n minus 4, which would be the same thing as 1 over 3 raised to the power n minus 4 divided by 4, right? So I can write this as 1 over 3 raised to the power n minus 4 divided by 4, and that is the fifth term from the end. That is the fifth term from the end. Now, what we can say is that now in the beginning we said that basically the ratio of the fifth term from the beginning and the fifth term from the end is in the expansion of this binomial is square root of 6 to 1. A square root of 6 to 1. That means that you can say that basically the basically n combination 4, 2 raised to the power n minus 4 divided by 4 times 1/3, and divide that by this thing over here, divide that by n combination 4 times 2 times 1 over 3 raised to the power n minus 4 divided by 4. That is equal to square root of 6 to 1, or you can just call it square root of 6. We can write it as simply square root of 6 would be the same thing, right? Now you can calculate n combination that is supposed to be n minus 4, right? That is supposed to be n minus 4. So that is n combination n minus 4. N combination n minus 4. Now to calculate n divided by n combination 4, n combination 4 by n combination n minus 4, you can write basically that is n factorial, n minus 4 factorial, and 4 factorial divided by n factorial n minus 4 would be equal to n minus n plus 4, which is equal to 4 factorial and n minus 4 factorial, right? So then you can simplify the numerator with this numerator, n minus 4 factorial, n minus 4 factorial you can cancel out, 4 factorial you can cancel out, the whole thing cancels out here. That becomes a 1. Which means that you can cancel out this thing with this thing over here. And so you can write this as 2 raised to the power n minus 4 divided by 4 divided by 2 would be equal to basically 2 raised to the power would be 2 raised to the power n minus 4 divided by 4 minus 1, which is equal to, now this thing over here, n minus 4 divided by 4 minus 1 is the same thing as 4 n minus 4 minus 4 is equal to n minus 8 divided by 4, right? You have 4 over here, n minus 4 minus 4 times 1 is equal to 4, n minus 8 minus 4, so that's 2 raised to the power, that is 2 raised to the power n minus 8 divided by 4. So that means that in the numerator I just simply write or let me do another thing in order to avoid confusion. What I'm going to do is that I'm going to write this simply as 2 raised to the power would be still the same thing. That means that if I divide 2 raised to the power n minus 4 divided by 4, if I divide by 2, that would be the same thing as this thing, 2 raised to the power n minus 4 divided by 4, and take this to the numerator, this becomes 2 raised to the power n minus 2 raised to the power minus 1, which means that you have a negative 1 over here, and then that would be again n minus 4 divided by 4 minus 1, and that would be the same thing as 4, so that you have n minus 4 minus 4, that would be n minus 8 divided by 4, right? So that means that you can just simply cancel out this n over here, this 2 over here, and then over here you can write 2 raised to the power n minus 8 divided by 4, and 1/3 divided by 1/3, basically you can write this as, this part over here you can write it as 1/3 divided by basically 1/3 whole raised to the power, this power, n minus 4 divided by 4, right? And so you can write this as basically 1/3 whole raised to the power 1 minus this power over here, which is n minus 4 divided by 4, which is equal to, which is the same thing as basically 1/3 raised to the power basically 4 So you have a 4 over here minus n minus 4, which is the same thing as basically, which is the same thing as 1/3 whole raised to the power. So what is this thing over here? 4 minus n minus 4 would be the same thing as 4 minus n plus 4. And that would be negative n plus 8 divided by 4, right? 4 minus n plus 4, that would be negative n plus 8 divided by 4. So that's 1/3 raised to the power negative n plus 8 divided by 4. So that gives me basically in the numerator I get 1/3 raised to the power negative n minus 8 plus 8 raised to the power 4, right? So that is basically, so far we can have the same, this conclusion, which means that basically you have basically 2 raised to the power n minus 8 divided by 4 times basically 1/3 raised to the power, let's say that this is basically 1 over this, so times, so you can write this as divided by 3 raised to the power negative n plus 8 divided by 4, and that is equal to, that you can write as square root of 6, right? Now in order, since the bases are not the same, but the powers could be made the same, meaning that if you multiply a negative sign by this, you could write it as basically 3 raised to the power negative n plus 8 over 4. You can write it as 3 raised to the power negative of n minus 8 divided by 4, right? So that would be the same thing as, now suppose that you have this power over here, so you have a raised to the power, for example, b, and c raised to the power, for example, say c raised to the power, for example, negative b. How would you simplify this? That would be the same thing as basically a raised to the power b times basically c raised to the power b, which is a times c raised to the power b. So which means that basically if I take n minus 8 divided by 4 as b, and so now if I write this as 2 raised to the power n minus 8 divided by 4, and write this as 3 raised to the power negative of n minus 8 divided by 4, right? Write it to this power, and if this is equal to the square root of 6, and if I take this power as b, I have a raised to the power b divided by c raised to the power negative b, which is the same thing as we showed here, is equal to a times c raised to the power b. So that means that this is 2 times 3 whole raised to the power n minus 8 raised to the power 4. And that is equal to the square root of 6. That is the same thing as 6 raised to the power n minus 8 raised to the power 4 is equal to the square root of 6. Square root of 6 is the same thing as 6 raised to the power 1/2, which means that then the indices are the same, so you can say n minus 8 divided by 4 is equal to 1/2, and divide this by 2, divide this by 2, 1, so that means that n minus 8 divided by 2 is equal to 1, which means that basically n minus 8 is equal to 2, which means that n is equal to 10. that is how you solve this problem. Hopefully this is the right answer. Let me see. I don't really know where are the answers. Question number 8 is n is equal to 10. That's correct. So that is, and as you can see in solving these problems, you have to basically be familiar with all of these powers of indices and everything like that. Meaning that if you have missed any of these before, you essentially have to go back and read all of those chapters. But of course, if you have any problems with those chapters, you can always let me know, because I have always wanted to, I mean, if there is any need really, I have always wanted to go back and do the basic chapters of these books. For example, class 6, class 7, there is still valuable things in there. For example, in geometry and things like that. So if you have any problems there, you can always let me know. I can probably try to fit that in and go back there and do those chapters for you. As you can see, all of those things are actually used here in order to solve a typical problem.